Hello, so we'll be looking at the homeworks from September 5th for the Algebra 2 and Trig Research Honors class. Alright, let's get started. The first question here, you have to combine them together. So this means 1 over 10 to the 10th power. Second one is minus 1 over 10 to the 11th power. The third one is 1 over 10 to the 12th power. Now we need to subtract all three of them, these two fractions from the first one. How'd you do it? Yes, well, one thing that we want to do is we want to make the common denominator. So, common denominator seems to be 10 to the 12th would be nice. In order for you to go for 10 to the 10th to 10 to the 12th, what I have to do is multiply top and bottom by 100. Then this becomes 100 over 10 to the 12th power. Minus, here, I just have to multiply top and bottom by 10, so we get 10 over 10 to the 12th power. Here, the third one is 1 over 10 to the 12th power. This basically means on the denominator we get 10 to the 12th power, but the numerator is simply becomes 100 minus 10 minus 1, which becomes 89. So our answer becomes 89 over 10 to the 12th power. Alright, let's talk about the second one. Here we have this expression has to be equal to 1. What does that mean? Either case number 1 is any number, so 0 power will be equal to 1. Let's try to look into that first. That means 2x minus 1 has to be equal to 0. If you have to calculate this one, yes, we get x equals 1/2. Now let's just check it. If you have to plug in 1/2 in the base, we get 1/2 plus 1 to the 0 power. Yes, indeed it becomes 1. That's fine. Second one, 1 to any power, 2x minus 1 will be also equal to 1. That means x plus 1 has to be equal to 0. Oh, has to be equal to 1. Sorry. That means x has to be equal to 0. So we have two answers. Now, third, if we have negative 1 to the some sort of an even exponent, let me just call it as 2k. That also will be equal to 1. So that means, let's see, x minus 1, or x plus 1 has to be equal to negative 1. That means x equals 2. Now, once you plug in 2 in place of x over here, we get x equals negative 2, my bad. So negative 2 plus 1 to the 2 times negative 2 minus 1. Is that in fact equal to 1? The denominator becomes negative 1, while the numerator, the base becomes negative 1, the exponent becomes negative 5. You see, it's an odd number, so this will not be equal to 1. Rather, it will be equal to negative 1. So therefore, third one wouldn't work. So our answers are 1/2 and 0. Number 3. So let us try to look into this one. First, when you have negative 1 as an exponent, what it does is that, as an example, if you have a over b to the negative 1 power, that's equal to b over a. We'll be simply getting the reciprocal of the given expression. So then here we have, if I were to get the reciprocal, I'm going to put the denominator as they are to the numerator. So this becomes c to the 4th power, b to the negative 5th, all over a to the 3rd, and c to the negative 2. Entire thing divided by a to the negative 2 power, and b to the 3 power. Next step would have been, let's organize the numerator for a second. Here, whenever I have a negative exponent, I will switch the location from numerator to denominator, or denominator to the numerator. Then here we get c to the 4th times c squared, and a to the 3rd times b to the 5th. Denominator now becomes b to the 3rd stays as they are, while a to the negative 2 power becomes a squared on the bottom. Now, if I were to combine the numerator of the numerator, we get c to the 6th power. Denominator is a to the 3rd times b to the 5th. Multiply that by, division by a fraction is multiplication by its reciprocal. So a squared over b to the 3rd. Then here we have, these two cancels out. We have c to the 6th left on top. On the denominator we have 1a left, a to the 1st power. And here, b to the 8th power. That is our final answer. Alright, let's look at number 4. How many consecutive zeros would you see at the end of 100 factorial? Now 100 factorial basically means we're going to multiply 1 times 2 times 3 times 4 and all the way up to 100. If you have to do this one with your calculator, you will see error or overflow. It's not going to work. We have to do another way. Now, but what do you realize about having consecutive zeros at the end? This simply implies that whatever the number, we multiply that by 10, then you will get 1 0. If you have 10 squared, then you're going to get 2 zeros. If you have 10 to the 3rd power, then you will get 3 zeros, and so forth and so on. But you see, having the idea of 10 is essentially 2 times 5. 2 times 5 gets you 10. If you get 10 squared, that means we have 2 of those. If you have 10 to the 3rd power, then we have 3 of those. So forth and so on. But you will realize that number 1 through 100, there are plenty of 2's because every other number has at least 1 2 because those are all even numbers. On the other hand, 5 may not be as common as 2. So since we have plenty of 2's, number of 5's will get us the number of zeros. So let's see how many 5's we have. Then basically what we're trying to do is this. We are trying to find the maximum number of 5's, meaning 5 to the n, that divides 100 factorial. Alright, first, multiples of 5's has at least 1 5 in them. That means such as what? 5, 10, 15. And so forth and so on. Another way for you to calculate that is simply 100 divided by 5, which is 20. There are 20 multiples of 5's from 1 through 100. But that's not all, because we have some other numbers that contains 2 5's, such as 25. Because 25 is 5 squared. Or 50, because it's 5 squared times 2. You see, multiples of 25 will also have additional 5's. So therefore, what we're going to be doing is 100 divided by 25. That's equal to 4. So we have 4 such numbers that contains extra 5. So therefore, when you combine them together, we have in total 24 numbers, or 24 5's are embedded in 100 factorial. So therefore, there are 24 consecutive zeros at the end. Alright, that's it. I'll see you later. Bye-bye.